Share my screen. Everyone see my screen?
Yeah, I can see it.
Okay. You can see it? Okay, good.
Yes, sir.
Okay, thank you. Today is October 19th. We're going to do practice lab for chapter 7, and then we're going to review for chapter 7, because on Wednesday we have a quiz over chapter 7. Also, I just want to call your attention to, on Wednesday, we are not going to start chapter 8. We are going to start chapter 9. Just for clarity, chapter 8 we're going to do later on in the year, near the end, because it's just sorting and searching all algorithms, which we already discussed one searching algorithm for you. But we'll go in more in details in that in chapter 8. But I wanted to pursue on to chapter 9, because chapter 9 is another confusing chapter when it talks about pointers. So I just wanted to get that over with so you get more time to digest that information. But just to call out, we will not start chapter 8 on Wednesday, but chapter 9. So if you're reading ahead, make sure you look at chapter 9. All right. The practice lab for chapter 7, as we move forward, we're going to enhance our seats assignment 1. But before I do that, I had this lab along a while ago. So I'm going to run this. And it's just in a high level, just to review arrays and a little bit of vectors. As you can see, I created these functions right up here, and I pass in arrays to it. I just wanted to go over this because sometimes it helps students to validate some of the information about arrays. It's a simple printout statement for the beginning part. I call a function print array. Here's my simple array, size 10, with these elements in it. When I call print normal loop, notice when I use the prototype, I would use the first one's the array, the second one is the array size. When I go into that function, it's just simple printing the array out element by element. But I just wanted to call out that right now, when we do it, remember, it starts counting with 0. This is a subscript, and it goes, since I have 10 elements, here's my 10 elements, but the index goes from n, which is 10, minus 1, so it only goes through 9. And I just do that quickly here, so it's this right here is using the enhanced for loop. That we cover, not the enhanced, the range base. I keep on wanting to enhance. It does the same thing. But remember, it doesn't have a counter to it, but I created a counter for myself. For double the array, this function right here, I pass in the same thing with the array. And I pass it right through and I double each element and I assign it back. As I mentioned before, an array's name by itself is the memory address to the starting point of the array. So as I pass in, after doubling, I display the contents back out, and notice I do not have 1 through 10 anymore. I have 2 through 20 because I doubled every element in and assigned it back. Because the array name by itself is a reference variable. When you pass an array to a function, it has the address. So after I double it, I just print the information back out. Notice right here, when I pass a single element out of the array, it does not change. When I pass an individual element outside the array, it's passed by value. So that individual element will not change the element in the array unless I use a reference variable to actually pass it. So notice when I did it by this way, passing a single element and passing element by reference, these two ways, if I do not have the ampersand right here, this one right here will not change it, but this one will. When you pass an individual element outside the array, it's treated just like any other primitive type. Any questions?
No.
When it comes to vectors, oops. When I initially create the vector right here, I don't have a size. I do not have anything. I gave a variable right here and I called it vector. But as you can see, size and capacity are both zeros. But as I go through this array, this for loop right here, I am constantly pushing things on. Vectors are unlike arrays, are dynamic. I can keep on adding and adding through the pushback because it adds like a stack. But notice after I added 10, the size is 10, but the capacity is 13. Remember, size is how many elements there are, but capacity is how many elements can that vector hold before it needs to ask for more memory. When you pop back the array, I can go through the elements in the array just like an array, but to remove it, I go pop back to remove elements from the array. Be careful if you do this, because if you pop back more elements than it is, it can cause your program to crash. But notice after I pop all elements out, my size is 0, but my capacity is 13. So size and capacity do not have to be the same value. Right here, I created a vector right here. When I pass in just a single argument right here, I give it initial size. This is just by chance that both size and capacity are both 20. When I added 10 elements to it, size and capacity are still the same. So I just wanted to call that out, the difference between size and capacity. Also, this was the error that I was mentioned before. If you pass in the array and you try to use the enhanced for loop, I have it right here. You'll get this kind of error message right here. Oh, where's my mouse? The range-based for statement requires a suitable begin function. I haven't researched why you get that, but if you use a regular for loop, it will not have a problem. And for practice purposes, if you want to try to break the bounds of the array, I think I have a function that does that. I can just easily do this. Well, there's one right there. But if I change this right here to be 10, 30, and try to run this again. You ever see this? Your IDE is sometimes what's called hang. Oops. See, word issues came on board. It still allowed it to go, but it's writing information to outside the array. So sometimes those situations be erratic to spot. Remember, C and C++ do not do bounds checking. Any questions on this basic knowledge of arrays and vectors? No? So let's go and look at our C++ file that we were creating before. Seats. This is what we had before. Simple, with function calls and everything. But what happens of the concept? Someone explain to me what a parallel array is.
You make two arrays that share an index. I mean, they have if you check the subscript on either array, they're related somehow for data management.
Very good. They're related. So now if we change this, and let's see, if I make a char array, seed array, seed type. I can make it constant or not. What about if I do this? A, B, and C. So now I have my seed types. Now I'm going to have my array of double, revenue per seat. I do the same thing, size. What I'm trying to do, I'm creating arrays for these. Then I will have 15, 12, 9. Now I also have double the revenue for it. Well, let me see. Let me change this to be cost per seat. Revenue per seat. For this one, this is going to be calculated, so I'm not going to give it any values. And then for this integer, seats sold. I'm just commenting these out. Now I have my arrays, all the same size 3, A, B, and C, double. These are costs per seat, and these these are revenues and so forth. Any questions so far? All I did instead of having it all by itself, I just created it. So I'm going to try to use the same logic that we came up with. So instead of calling this ticket sold with A, B, and C, what could I write instead of doing this over and over and over again?
Do you think you could do a function with an ampersand?
I can create a function, but let's just keep it simple right now. What can I take instead of putting this and just replace it from this one line?
Wait, what? I didn't hear what you said.
What can I take away? What can I replace this instead of doing the function? I'm not going to deny functions, but what about for keeping simplicity? What can I put right here to replace this for me the same seats?
Create another array and ask and put the data into that array.
Well, we already have the array. So right now we have for integer index, and just start with 0. Index less than size, because we have the size right here. Index is incremented, right? So that's going to give us to go from array 0, 1, and 2, correct?
Okay.
So right now, the seat sold at that particular index is equal to ticket sold at seat type at that index. Let's do it a better way. That's fine. My revenues is unreferenced variable. That's just a warning. Oh, index right here. As you can see, the code changes that we had, we don't have tickets calling this function again, ticket sold, ticket sold, ticket sold, ticket sold. So I'm using this trying to say with the same functionality that we had before to reuse it. So all this is correlated to the same index. So this A, when I type in seat sold right here, it corresponds to A would correspond with index 0, 1 would be with B, and same thing 2 would be with C. Any questions on that?
I guess so far so good right now.
The reason that this comes to be useful because what happens later on if we go right here and say, oh, we now have 5 seats, 5 different types. We have it more maintainable because then we can just add different things in. We can add D and E. But see how quickly this becomes really easy to maintain. I don't have to write tickets. Now if I have tickets sold for D, E, F, and G, I don't have to copy and paste this all over. So then from here, how can I get revenue for each seat?
You could do a for loop and then iterate through the revenue for the seat, right? So you can create a for loop and then you could iterate through the which array was it? Revenue per seat. You could iterate through that array and then you could set whatever index as the cost per rate.
Could I use the same for loop?
Yeah, you could do that.
So what would I put? Because the array right now is revenue, right? Per seat. That particular index is equal to what? We know the seat type. We know the ticket number. Right now, our ticket number would be, I think it'd be the array would be seats sold, right?
We set the we already set the value for seats sold, so
But that's the way we have to multiply it because we do that. The price times the tickets, how many tickets we sold for it, correct?
okay.
So the seats sold, the number of things we sold, times by
Oh yeah, then where
cost per
was
seat.
it? I think we did something for getting, because we have seat type and what was I gonna say? Didn't cost per seat. No, I thought there was something else for thought there was like a function or something that would try to get what seat type, or no. Are they the same are they the same pricings for each iteration or not?
No, each iteration they're different because remember that's what parallel array is. Each loop it corresponds to the next one. So maybe if we do this which helps us out. First iteration, index the seat type, and then the cost per seat. So the first iteration would be index 0, right? We start with 0. But seat type at seat type at 0 is what? Seat type at index 0 is A, right? And so it's 15. So the next iteration we have through index is 1, C type is B, and so forth, and that would be 12. And so forth. Does everyone start seeing that? As each one of these goes, it corresponds to, it all links with that index.
Yeah, I see it.
So now we got rid of all of this. Now could we get rid of this part right here?
I think you have to specifically keep that one for just specifically keep that one because, or how about you could declare the grand revenue is declared, yes. So how about in
I
the
mean,
for loop? you could add an iteration. In the iteration, you could add grand revenue and then add plus equals, and then the revenue per seat, or was that? I think that was right.
I think you're on the right track. Revenues per index. Ow. This is now gone. Now, can we clean up this part? All this formatting stuff.
I believe you could make it. You could put also in the folder, but you could put the formatting inside the folder, but then when you do see out, then you're going to you can have two see outs. So you could put the formatting in the for loop, yes.
You want to create a separate for loop to display all this stuff, or you want to put in the same for loop?
Oh, the same one.
Okay, let's try it.
I would probably put it in a different one because every single iteration, it's going to display the same thing. You're going to continue to display it every single time instead of at once or just one single time.
Either way, it can be correct because when you go through it, each one, remember, it's still going to print off. If we mark it correctly, it's not going to say type A, type B, type C. It's going to actually specify what is at that particular index. So,
This one in separately because
yeah, this
it's all
last
the
line was
same.
grand revenue, yes. So this grand revenue would have to be outside them all. So let's just quickly, we'll try a separate for loop, but you could probably put in the same one. But let's try two separate to be clear, to be clean. I can use the same index, but I'm going to put this part right outside. And I could put C out. Type C type. At a particular index. Revenue is put a new line. Revenue versus. Right?
We've got end line.
I put inline, or it's going to reprint right here with this new line right here. We can always do formatting later. Because next time when it goes to this loop again, it's going to go to an end line right here, new line right here, and start all over. And then grand revenue. Let's see if that works. Because it's an accumulator, we should give it initial value. Because right here, when you first time using it, we are accumulating. It's already open. Oh. Any questions so far?
Cool. That was interesting. That was. I feel like. I feel like so far what you're doing is this code is very maintainable, and it could be, and if you wanted to change something, it could be easily done with like three keys.
Say it one more time. You're on the right track. I heard it, but I didn't hear it all. But you're correct so far with what I heard.
Okay, so I was saying that I think like how you're doing this overall, I think it's getting like very maintainable. So because say you wanted to add a letter or add an extra revenue, then all you need to do is type like 4 characters, and it would be all changed up.
Exactly. So if we do, let's say, do it right now, 4. All we have to do now is just change this. Let's say add a D. If we had another price right here, let's say $5. Let's run it again. Build solution. See, we made this code. We can refine it even more. Like you said, we can create these as functions and so forth. But as you can see, from where we first started off, we first did this in lab 3, and we did all the loops and so forth. We never changed the code because we can still do the negative testing too, because we add that in. But as you are very correctly, the code becomes very well maintainable and easily updatable. So can you see the progress that we made from chapter 3 when you first did it to now?
Yeah, definitely. I kind of at first and before then, like starting this class, I feel like because I already had like plenty of coding experience, I kind of was thinking about like how the code is just very long, and I was always used to writing short code that's very maintainable and still gets the job done.
Mm-hmm. And as you can see, as you write this code, the code is becoming very short now, because you got to think all this now. I'll keep the revenue. Instead of doing the C out to a file, you can replace all this. So technically, all this right here commented out could be replaced to an output file too. See, we can create this as functions and make it even shorter and reusable. Because like, for example, on this one right here, when we validated this part right here, we can create a function later on when you get more advanced and say, instead of passing all this, you can pass it in a list of valid criteria and put that in a utility class and reuse that over and over again. You write it once and you put it in a different file and you reuse it over and over again. So, and later on, if you go to more advanced, you would start knowing about automation and unit testing, that this function of code right here could be pulled out and tested and automated just this function alone. So if someone else changes this and it breaks, it will break the build. So you can automate this part and testing some to make sure anyone else doesn't change it. But that's what I wanted to show you from as we go from chapters 3, 4, 5, 6, and 7, how we progress. Very good. And when you start writing your own code, when you start doing your lab 4, this I want to see reusability. Not so much copy and pasting code to reuse it. Yes, we could have taken this one right up here and moved it inside here and displayed. But sometimes having it separate, I could have created a function right here right here, gutted this out, and passed in all my arrays to it, and just had a function itself that says print info, print array info, whatever you want to call it, print C things, and pass it all and not keep it all in main. I could have created a function for it. So that way, there's nothing really in main except for passing the variables around. Any other questions? Very good. So let's see how good you're at your knowledge base on chapter 7. Let me blow this up a little bit bigger. Can everyone read this right here on the screen? Review questions and exercises.
I see them.
All right, let me get the chat thing right here. Contents. Fancy people's names. How many of you text me if your mic is not working, or send a message on that chat if your message is not working? Does everyone's mic work? So everyone's mic works, correct? Let me see.
Says mine doesn't work.
Which one? I know Stephanie says it doesn't work, and who else? Stephanie and Justin. Okay, Stephanie and Justin. They could do the true false ones.
Hey, my mic is working too.
Is this Justin?
Yes, it is.
Okay, so it's just Stephanie. Okay. Let me see the participants on it. Okay. Usan, what is the difference between size declarator and the subscript?
It says how big it's going to be. The subscript is an index that is assigned to each of the units within it.
Very good. And to add on to that question, do I have to have a size declarator for every array that I initialize? That's vectors.
Oh, sorry.
Well, why not? You're right. I don't have to have a size declarator for every array that I initialize. But if I do not have its size, what do I need to give it?
Initial value?
Close.
Okay.
Close. You need to give it, in this case, if I do not give it, like right here, revenue per seats doesn't have this, but I could take this cost per seat and take this out because I have it explicit elements. So you're on the right track. If I do, I need to still have the square brackets, but if I don't have a size declarator, I must give it the values in the array. All right, let's go back to.
Could that reduce the amount of the size declarator produces it, and then if you just leave it out, it just adds it in automatically?
But but with the size declarator, remember, if you have to give it the exact number of elements of a list like A, B, and C. But let's just say I have size of 5, but I only give it a list of 3. The array still has 5 places it can handle. So if you give it no size declarator but an explicit list of values, it's going to calculate that size based upon those values that you give it. So that's going to be, and that's going to give you the size. However, you can have a size that's different from the explicit list that I give it. So it's either way that you want to give it. I don't think it gives a number performance-wise. It could be because it probably would have to calculate. I would always want to give it the size because then I can pass the size around.
Okay.
But okay, that was Suzanne. John, look at the values in the array. How many elements does the array have?
Going to be 10.
How was your day? Stuff like that.
10. Yes.
Yeah.
I think Justin Farmer says he's the one that doesn't have the mic working, correct?
No,
it's
that's
no,
no,
his
it's
work.
only Stephanie. Okay. What is the subscript of the first element in the array, Justin?
Subscript. Wait, subscript of removing it?
No, what is the subscript of the first element in the array? Right now, we have int values of 10, and we didn't list it. We didn't tell it what the values are. So what is the subscript of the first element in the array? If I want to access the first element, what would my subscript be?
Oh, wait, so 0?
0. Michael, what is the subscript of the last element in the array?
9.
9. Assuming that an array uses 4 bytes of memory, how much memory does this take? Murray. Murray, are you there?
Yes.
What's the next question? Assuming that int uses 4 byte memory, how much memory does this array use? Think about it. If I have int is 4 bytes and I have 10 of them, how much memory is that?
$20.
I'm sorry, what number?
20.
No. Brian, Carolyn, can you help him?
Wouldn't it be 40?
40. Very good. 70 doesn't have a mic working. Go back to your son. Why should a function that accepts an array as an argument and process that array also accept an argument specifying the size? This is a good one for your labs because this is very important. This question. Why should a function, this is for Hussein. Hopefully I'm saying that correctly. If not, Hussein. Why should a function that accepts an array as an argument and process that array also accept an argument specifying the array size?
Wait, it's still saying the same thing to it? Is redundant information for it? Because you're passing to it the actual location of a certain thing.
Well, think about it a little more clearly. You're writing a function, and your function has a placeholder, correct? And you can write that function over and call that function over and over again, like average, grades. Each array that you pass it has a different size. You write a generic function that does something, and you will not care what the difference is because you're passing that to that function so you can use it in that function. Yes.
Wait, so you're asking the difference? I thought you were asking why.
Why should a function accept? Why should a function that accepts an array argument should also pass the array size? Call a function.
Oh, okay.
Array.
Okay, the question is, should you give it the array size when you put it in, basically?
Why should you? Yes. Why should
Oh,
you?
okay. Well, I mean, within the function, if depending on what you're doing with the array information. So like if you run basic, like what we did for loop, where you want to run through every single element, then it doesn't really matter because you can just go through the next one. But then if you want to stop somewhere or you want to specify the size for the function, for this function, then you'd have to have it so that it would stop and doesn't override further than what's the capacity.
Yes. Well, not necessarily for the capacity too, yes. But there's other ways that you can get where you don't need to pass the size to it. There's a way of calculating it. But for simplicity, if you pass the size in and you pass it to that function, you can write your function to say, hey, find me the average of this, find me the summation, or do some kind of standard deviation on this array. But I'm passing the array and the size. So technically, I do not care how many elements are in that array because I'm always passing it to you, so I can use it over and over again. So it's kind of make it more generic, but very good. John, consider the following array definition. What does each of the following statements display? Just do the first one. What does the first one, C out 4, do? What would that display?
Should display 8, right?
Right now, you have values right here.
Yeah.
Right? And you want, and it's a C out values at index 4. What's going to be displayed?
Oh, 2. Sorry.
2.
Yeah.
Justin Farmer, what is the second one?
The second one is values to 14.
14. Michael, what does this one do?
It's gonna increase it and then display it.
What's going to display?
Well, it would display 7.
No, think again, you got this right in front of it. What did we say with the pre-increment? It does.
So is that gonna display 6?
No, because right now you're saying values at 1, 0, 1. We're at 7, but pre-increment it. It's going to display 8.
Okay.
Remember, this is a pre-increment that says, take this values right here at this location, which is 7, 0, 1, pre-increment me. So now I'm 8. And notice where the location is, because it's a good question, because this says right here, since it's outside of this whole thing, it's talking about the value in that array. If this increment was inside with the variable, it's talking about the index. So make sure you still remember pre and post. That was Michael Gay, correct?
Yes.
All right. How do you define an array without providing the size decorator? We mentioned it just a moment ago.
Well, I guess you just leave the bracket open.
Say that one more time.
You leave it open.
What do you mean leave it open?
I don't know how to explain it. You know.
Like right here. Are you saying like right here, I'll just leave it open like this on like number 18?
Yeah.
Right now I have an error. Try and do that. If you do not specify the size decorator, you have to give it what? you have to give it an explicit list of values.
Couldn't you leave it without a size declarator and also leave it open without defining it, get the user to input it?
Say that one more time.
Instead of defining it, couldn't you just get the user to input it even without the size declarator?
No, if you don't have the size right here, you have to, if you don't have the size, you have to give it a list right then.
Okay, so you couldn't leave that uninitialized list?
No, because then how would it know, the operating system know how much memory I need? So you either have to give it like this, the size, or the list, or both. You have to give it something. All right, let me see. That was Murray, right? Okay. Rylan, look at the following array right here. What value is stored in 2 in this subscript right here?
Wouldn't it be 3?
3. Susan, what is the next one?
It's a global variable, so I assume it's just garbage value. Is this
No.
outside the array?
In this case, since we partially give it, it will initialize it to 0. Look at the PowerPoint slides again. But you're right on about the global and local. But the thing it says, if you partially initialize an array, the uninitialized element, if it's numeric, would be a 0. We'll go back and look at the review slides, but this one would be a 0. John, assuming array 1 and array 2 are both arrays, why is it not possible to assign the contents of array 2 to array 1 following statement?
I can't remember. I just know it's not possible. I remember you going over it, but I can't remember why.
Yeah. Array name by itself,
Oh, yeah.
no
Yeah.
brackets is what?
It's a reference.
It's a constant
Oh,
memory address of the
Oh,
starting
yeah.
array.
Oh, yeah. Just
So
by
that's one
itself.
reason, because you can't change it because it's constant.
Okay.
And to copy array, you have to go through each element.
Okay, so yeah, it's just constant. Yeah. Okay.
Justin, assuming that numbers is an array of doubles, will the following display the contents of the array?
Number 7?
Number 8. Or number 8.
Oh, all right. Assuming that number. No, you said that that it had to display. We had to display the specific index. So a for loop, and then we print it.
Yes, you have to. So the answer to this question would be no. It would not display all the elements in the array. That is correct. But if it was a character array, yes, it would. Just remember that. We'll cover that in chapter more in 10. But if it's character arrays, specifying the name, it will display all the characters. But for numeric ones, no, it will not. That was Justin. Michael Gary. Is an array passed to a function by value or reference? And why?
Reference, right?
Why? You're right. Why?
I can't actually remember why. I just remember it's passed by reference.
We talked about it like 2 minutes ago. Who did number 7? Who did number 7?
Yeah, that was me.
Because it's the memory location. It's
Yes. The array name by itself with no brackets is the constant memory address of the starting point of the array. So want to beat that in because it's going to come again in chapter 9. That was Michael. Murray. When you pass array name as an argument to function, what is actually being passed? Murray?
I don't know.
You just had 3 or 4 questions covering the same thing, so it's kind of an important concept.
It's an argument.
You pass an array name as an argument function. What are you actually passing it? Rylan, can you help him?
Is it by reference?
What is the reference? When you say I'm passing a variable as reference, what are you giving it?
A parameter?
A what?
A parameter?
A formula?
A parameter.
No. Husan, can you help him?
You're passing the actual memory address?
The address. It's we just talked about this 3 or 4 times using the same thing, array's name. So it's an important concept because it's going to come up again. So that's why I kept on hitting it, you guys, over and over again regarding array name by itself is the address. It's going to come back in chapter 9 when you talk about it on Wednesday. Because pointers, when you talk about pointers, we are going to do nothing but talk about addresses. And we're going to also talk about a different way of passing a variable to a function. And that's using another way of passing the address. So these are concepts, so that's why I want you to understand them clearly before you go to chapter 9. John, how do you establish a parallel relationship between 2 or more arrays? John Arnold. We just did it for lab.
Yeah, the parallel, they run side by side, never intersect.
How do we establish the connection between array 1 and array 2 and array 3?
I was right. There's nothing. It was probably just messing around.
I know we just did it, but I can't.
Justin Harmon, how do we get a link between those parallel arrays which never intersect and they have the same size? What links them?
It's values.
Nope. Michael Gary?
Subscripts.
Subscripts.
Yo, I thought that was the same. Yo, I thought that was the same thing. Okay. I thought it was like the similar. No, yeah, I meant to say subscripts, but I thought values was like because they're both like corresponding with whatever relationship.
The difference between that is the index what it points to. A value I took about is what is in the address. That's the value, like $12, $10. That was Michael Gary. Murray, look at the following array definition. Now we talk about multi-dimensional arrays. How many rows does this array have?
Ten.
No? 8. Think it's 8. Rylan, how many columns does this array have?
Wouldn't it have 10?
10. Son, how many elements does this array have?
80?
I'm sorry, say it one more time. I think you said it correctly. I just want to make sure here.
80?
John Arnold, write a statement that's how would you store something in the last row and the last column? What 2 values would you give it?
Are you talking like in the subscript? Like what it would
Yes.
be?
How would you give it on the subscript?
It would be, well, I know it would be 79, but
7 and 9. You're right. 7 and 9 because the last row value subscript would be 7 and last row column would be 10. Now to add on to that, Justin Harmer. If I'm going to pass this array to a function, okay, the question comes in number 13, so I was going to answer it, but it's already given in 13. Write a function that accepts a two-dimensional array as an argument. Which size directly must you provide in the parameter for the array?
All of them but the first one?
Very good. Very good. Yes. Okay. All right. What advantage does a vector have over an array?
Oh, my bad. I think I answered for the last one.
Oh, I'm sorry. If that was Michael, then it goes to Murray. Murray, what advantage does a vector have over an array? Murray? I guess he lost it. Okay.
It holds multiple values.
Say that one more time.
Multiple array holds multiple values.
Well, they both will have multiple values, correct? Array would have multiple values. A vector will have multiple values. It could potentially have multiple values. Rylan, what's the advantage of a vector?
I'm not really sure on that one.
Husan?
Vectors are dynamic.
Very good. They can grow and shrink. Arrays are static in size. You specify the size and they do not change. Let's see how clear you're on. John, the blank indicates the number of elements or values an array can hold.
Isn't it just how many you put on the?
What do we call it? What do we call that in that square bracket when you initialize an array, when you give it, what is that value called?
It's not subscript. It's
Look on the screen and look what I'm highlighting.
size decorator.
There you go. Justin Harmer, the size decorator must be blank with a greater than blank.
It must be an integer with
Greater
a value greater than 1. Wait, no, greater than 0.
Zero. Okay. Each element of an array is accessed and indexed by a known as what?
I'm sorry, my screen just went black. Can you say that again?
Each element of an array is accessed and indexed by a number known as
The subscript.
subscript. Right. Subscript numbering in C++ always starts with
1,
no
0, sorry.
0. 19. Rylan. The number inside the square brackets of an array definition is the blank, but the number inside arrays brackets in an assignment statement or any other statement works the contents of the array is the blank.
Isn't the first one value?
I'm sorry, what's the first one? You're kind of breaking out.
Value?
No. Look what's highlighted on my screen.
The size decorator?
The size decorator is the one we did the definition. And then And the other spot is what?
Subscript.
Subscript. Son, C++ has no array blank checking, which means you can inadvertently store data past the end of the array.
Checking.
I'm checking. John Arnold, starting values for an array may be specified with a blank list. John Arnold?
Yeah, I'm here. I'm just thinking.
21. Starting with the values for an array may be specified with a blank list.
Is it like initialization?
Initialized list, yes. Justin Harmer, if an array is partially initialized, the uninitialized elements will be set to
0.
0. If they're string, what would they be associated with?
One.
No, someone said it. 23. Michael Gary, if
Wait,
the
what was
size
that?
Go ahead.
What was
No.
LB?
If the size declarator of an array definition is omitted, C++ counts a number of blank in the blank to determine how large array would be.
In the initialized.
Yes. Initialized list. Yes. Murray, by using the blank to multiple arrays, you can build a relationship between the data stored in the array.
Subscript.
Subscript. You cannot use a blank operator to copy one array to another in a single statement. That's right.
The equals operator?
Excuse me, what do we call the equal?
Oh,
Starts with an A. I'm not going to put the other two letters in it right now, but
yeah.
it's the assignment.
Yeah.
26.
The ampersand? Not the
What?
ampersand. I said the ampersand, not the ampersand operator. It's the, I can't remember the name of it.
This one right here, you got equal, but it's called the assignment.
Okay.
That was right, Lynn. So, anytime an array name is used without brackets and it's subscript, it is seen as a what?
Memory address.
That's like a fifth or sixth question on this. So you kind of tell it's kind of important. 27.
Easy, stop!
Pass the array to a function past the blank of the array. John Arnold.
Isn't it the reference? No.
You also, it is a reference, but what is it you pass to the array? What is the actual argument you pass to it?
If I can get you a motel.
I guess I don't know the actual name of it.
Just Harmer? What is it? To pass to the function, you pass a blank of the array.
You pass the. Well, you do pass the data type. Wait, yeah, the data type of the array.
Well, that's always given. You always pass the data type, but what do you also pass in to it?
You pass empty array, right? I thought that's what. No, you pass the variable name.
Variable name. I'll
Right?
give that. It's the array name. I'll give that one. To pass array to a function, you pass the name of the array. So this would be name. So that was just Harmer. Michael Gary. A blank array is like several arrays of the same type put together.
A parallel array? Or, yeah.
Yeah, multi-dimensional array. Yes, 29. All right. It is best to think of a two-dimensional array as having blank and blank. Murray?
Um, um, maybe column 1 and 2, or 2 rows.
No, not two rows, but rows and
Columns.
columns. Murray. That was Murray. Rylan. To define a two-dimensional array, blank size circulators are required.
2.
2. Busan, when initializing a two-dimensional array, it helps to enclose each row initialized list in. Very good. Donald, when a two-dimensional array is passed to a function, the blank must be specified.
The blank size, the integer size?
You already have a two-dimensional size, and let's just say they're all ints.
Okay.
So what size you must pass it? Think of it as questions. You have two-dimensional array as having rows and columns. Which one of these do you need to pass it? You need to give it rows or you need to give it the columns?
Don't you need to give them both?
No. When you use multi-dimensional arrays, you pass all dimensions except the first.
Oh, okay. So the columns.
So
Can you just pass the first or no?
no, I haven't tried to see if you can pass the first one as also. I haven't seen if you got compilation errors, but by syntax rules, you need to pass all sizes except for the first one.
Why? Do you know
33.
why that? Do you know why that is? It just seems really random.
I think it's something to do with the way the memory location is able to handle it. That's my guess. That is my guess. I don't know. I would have to look it up. I don't know. 33. I'll answer this question. The blank is a collection of programmer-defined types and algorithms that you may use in your programs. That's the standard template library. I don't know if you got that in your reading, but I'm giving that one. Also with this one, the two types of containers defined by the STL are sequence and associative. I'm not going to ask those too much in details about them, but I just wanted to give you that information in case it does come up. And the vector data type is a sequence container. We're not going to go into too much of that, but I just wanted to give you those answers. And
it's the 34 is sequence and what?
association.
Okay.
Vectors are data type of sequence containers. To define a vector in your program, you must use the which preprocessor directive. Who was the last one? Was it Rylan? What was the last one?
I think it was John or Justin.
Okay. We'll go with Justin.
No, okay. Yeah, it wasn't me who did the last one.
Go ahead and answer. We'll just start with that one. To define a vector in your program, you must include which preprocessor?
Vector.
Vector. Michael Gary, to store a value in a vector that does not have a starting size or is already full, use a blank member function.
Would it be the braces?
No. It's a function. What function would you call?
Oh, okay. A pop back.
Pushback.
Pushback. I'm sorry. Yes.
All right. To define the number of elements in a vector, use a blank member function.
I don't know that.
We discussed. We had this before. Rylan, to determine the number of elements in the vector, use a blank member function.
Is that the one, the size vector?
Size. Very good. Husan, use a blank member function to remove the last element from a vector. John Arnold, to completely clear the contents of a vector, use a blank member function.
Maybe get a sweet place like this.
It's not swap. Exit or clear.
Where do you go from here?
Clear. Everyone get their texting on your messaging, and we'll answer these multiple choice true false ones, and then we'll wrap it up. So I'll just see everyone's text. 50. Oh, hold on. The array size decorator can be either a literal, a named constant, or a variable.
Doing the same thing.
True or false? False. It can be a literal, it can be a named constant, but we didn't talk about a variable.
Oh, and I'm just this time around.
To calculate the amount of memory used by an array, multiply the number of elements by the number of bytes the elements use. True or false?
I guess you could say it looks like the same thing over and over.
If you just do text or just shout it out, to calculate the amount of number used by an array, multiply the number of elements by the number of bytes an array has. That is true.
Same thing over and over again.
52. The number of elements in an array are accessed and indexed by unique numbers. True. 53. The first element in the array is accessed by subscript 1.
We decided to get clean. It's not
Very good. It's 0. 54. The subscript of the last element in a single dimensional array is 1 less than the total number of elements in the array. True. 55. The contents of an array cannot be displayed with cout. Let's just make this clear. It's a numeric array. If it's a numeric array. So that's false. 56. The subscript numbers may be stored in variables.
Disarming, you might say.
True. Because how are you going to go through them? You use variables. You can write a program that uses invalid subscripts for an array. Yes, because remember, right, it does not do bounds checking. 58. Arrays cannot be initialized when they are defined. A loop or other means must be used.
Shapes. I wouldn't know. What?
False on this one. They can be initialized. You give them a list. You give them the very first. Yes, so this is false. 59. The values in the initialization list are stored in the right order in which they appear in the list. Yes, that is true. 60. C++ allows you to partially initialize an array.
Just want to be careful.
Yes, true. If the array is partially initialized, the uninitialized elements will contain garbage. Very good. False. If you leave an element uninitialized, you do not have to leave all the. If you leave an element uninitialized, you do not have to leave all the ones that follow it uninitialized. False. If you start, you can't. You have to give it the royal ones first. Once you start giving it uninitialized, you can't skip. Very good. 53. If you have the size decorator of an array, you do not have to include an initialization list. 63 is false. That's good. The uninitialized elements of a string array will automatically be set to value 0. False. Very good. You cannot, at 65, you cannot use the assignment operator to copy one array's contents to another in a single statement. True. When an array name is used without brackets and a subscript, it is seen as the value of the first element. False. It's not the value, it's the address. 67. To pass array to a function, pass the name of the array. Very good, true. When defining a parameter variable to hold a single dimension argument, you do not have to include the size decorator. That is true. You do not have to for a single. When an array is passed to a function, the function has access to the original array. Very yes, you pass the array, you pass the memory address in. 70. A two-dimensional array is like several identical arrays put together. It's kind of, they kind of say yes it is, but I can argument either way back and forth because rows and columns could be different. So for this one, two-dimensional arrays is like several identical arrays put together. I think they're kind of addressing this question as they are all the same data type. So it would be true, but I can understand the argument the other way, that if they have different size, they're not identical. So don't worry about this type of question because this can go either way, because you can argue, well, the arrays and rows and columns are 8 and 10. They are different sizes, so they're not technically identical, but they are identical in that they all the same data type. So I can see this one going either way. 71. It is best to think of a two-dimensional array as having rows and columns. True. The first size decorator, that is 71, is true. The first size decorator in the declaration of a two-dimensional array represents the columns. The second one represents a row. False. If you look at the previous questions, then that would be false. 73. Two-dimensional arrays may be passed to a function, but the row size must be specified in the definition of the parameter variable. False. It's not the row, it's the column. 74. C++ allows you to create arrays with 3 or more dimensions. Yes. A vector is an associative container. It's a sequence container. So yes, that's a false. To use a vector, you must include the vector header file. True. Vectors can report the number of elements they contain. Very good. True. You can use the bracket operator to insert a value into a vector that has no elements. False. False. You have to push it in. If you add a value to a vector that is already full, the vector will automatically increase its size to accommodate the new value. True. That is true. Very good. And that's the last of the questions. And chapter 7, let's quickly go over, make sure we didn't miss anything. About arrays, because that's what we cover. Access, being able to access the array elements. No, understand that. Be careful about breaking the bounds of the array. Remember, global variables are initialized to 0. Local variables are uninitialized by default. However, if you partially initialize the local array, the uninitialized ones are going to be 0. No bounds checking. The range-based ones know about how to use range-based. That if you do not have the ampersand, it's passed by value. But if you use the ampersand, it's passed by reference. Processing the array, be careful of what you remember about the post and pre. Remember with character arrays like this, if you display the full name, it will display it all. Characters will display Henry in this case. But for numeric values, no, it will not. Summing, these are good things for your labs, so I'm not going to go over them. Parallel arrays, we discussed them. They're the same size. They live by the subscript. About multidimensional arrays. You have to specify all dimensions except for the first one. And know some of the core member functions of the vectors, how it handles, push back, pop back, capacity, size, clear, reverse. Know some of those ones that are listed, empty. Know what they mean, like right here, reverse. Any other questions or concerns regarding Chapter 7? Let me stop. No?
I was saying I'm good.
All right. And remember, on Wednesday, we will not be covering Chapter 8. We'll be doing Chapter 9. I recommend perusing a little bit about the PowerPoint slides. We will be talking about pointers and another way to pass parameters to functions as pointers. Pointers are get a little bit more confusing, but it's a simple concept, but there's a lot that you can do with them. And keep an eye on the schedule when your Lab 4 is due. I don't know right at the tip of my head. I have to look on the syllabus. That's coming up, and also give ideas for what you would do for your Lab 6. But any other questions or concerns to this classroom up to this time?
Mhm.
Okay, I'm going to stop recording.